take a look at this one. This is positive. This is negative. Guess I could zoom out a little bit, couldn't I? So you can see what's going on. I'm suspecting a open AVC capacitor here, and usually heating them up with a soldering iron will kind of get their juices to flow a little bit and get their ESR to drop down from several thousand ohms to lower several thousand ohms. So let me get it apart. So it appears I was way off. It's one of these. There we go. We just hit takeoff. I knew I'd get it. After I blew everybody's ears out, I knew I'd get it. Okay, you know what? Let me just recap this damn thing.
Chef, military veteran, worked in the White House as a chef for 4 administrations.
Okay, I'm going along with the recap here.
Chef, thanks for being here. First off, how much
And these are Echo brand capacitors. And I got one left, which is the one off the volume control, which is right here. This thing sounds like it's got a bad speaker. It's like something shorted. Like the speaker is shorted. And the speaker looks like it comes out the front. Well, it's not the speaker, but it's driving plenty of current. I mean, it's acting like the audio output is working. .38 milliamps. Idling at 11.9 milliamps. So what's shorted? It's driving 36 milliamps into where? Where's that audio going? Because it's definitely not coming out of this. Did one of the... No, the output transistors, I don't think they would cause this because it's idling at 11 milliamps. Huh. All right, let's do the signal tracer. I disconnected the speaker here.
In 2004, and it allocated billions of dollars to stem cell research. They even approved more funding in 2020. Well, how much in the field of stem cell research has been made over the past 18 years? He's with us now. Director of the Stanford Institute for Stem Cell Biology and Regenerative Medicine. Gentlemen.
Well, I had heard about Prop 71 passing, which gave to fund stem cell research.
Get up.
At some point, I realized that there were a number of clinical trials going on, which would
That's coming out of the volume control. I hope you can still see me here.
Number 312.
On a gun bill that nobody has read, not a single person has read. And I'm like, well, these Republicans vote for this, standing up against.
Campeón nacional para la próxima temporada. Esta será en la tercera ocasión en Guatemala del técnico nacional de Ciudad de México.
Okay, it sounds good coming out of the volume control. It sounds like garbage coming out of the driver transistor. I disconnected. Try and get this thing on. I disconnected the volume control from the first audio transistor. You listen to it here.
Don't have much time to get Orca.com and save $150 on a 3-month emergency food kit from My Patriots.
Okay, listen to when I connect the volume control to the first audio transistor.
Have this food. Most of all, you'll be prepared for whatever happens next. Go to preparewithgorka.com and save $150 on a 3-month emergency food kit. It's a great deal and will give you.
Is that a bad detector diode or bad first audio transistor? I guess I better check the detector diode. The detector diode measures 248 millivolts one direction, and I've got it out here. And open the other direction. It is not. It is good. Yep, it's good. Open one direction, 250 millivolts the other direction. And it wasn't even soldered in. I just pulled on it and it fell out of the board. And I thought this was going to be an easy one. Okay, here are our voltages. On the first audio amp transistor base to emitter, negative, well, forget negative, positive, 0.117. That seems kind of low. Collector to emitter, 4.6 volts. Collector to base, 4.5. Okay, and on the driver, emitter to base, 0.14. That's a little better. And from emitter to collector, 5.1. So is this driver transistor shorted? It's not shorted, but it might be leaky shorted. Well, I found another problem here on accident. Right there at the tip of my finger, the connection to the base of the output transistor is broken. Let me fix that. Okay, I changed the pre-driver transistor and I fixed the solder joint. This helped a little bit, but I still got this growl, this rumble, if you listen real close. It sounds very thin, and it has a rumble to it, like a oscillation motorboat, but it's not this transistor. I gotta be honest, I'm a little bit lost as to what's wrong with this, with the kind of motorboating distortion that really appears to be coming from the audio amp. When I had switched the pre-driver transistor out, I checked all the resistors, I had them out, they all seem good. Right now I have the audio line from the detector that goes to the volume control disconnected. I'm going to feed the signal generator into it with a 1 kilohertz tone, and we'll look at it on this little play scope here, which is pretty cool. It only goes up to about 30 kilohertz, so it's perfect for this. Right now I'm just going direct, but let's see what it looks like. Let's see if we see anything feeding 1 kilohertz from here into the volume control and then connecting the scope across the speaker. Okay, yeah man, look at this weirdness. If I can show it here. I'm going to come up on the volume. So all I'm doing is adjusting the volume, the input. But then if I go up in frequency, and that right there is what we're hearing. What's the frequency response of this thing? That's 5 kilohertz. That's 15 kilohertz. That's some weird freaking behavior. Look at that. Looks good at 2.5 kilohertz, but man, you come down here. Now what the hell is that right there? This is what it looks like on the base of the first transistor after the volume control. Why? Why does it look like that? And then this is the base of the second transistor. And it's trash. Why is it getting trashed? And that's the same thing we saw where when we hooked it up to the signal generator, I mean to the signal tracer, it was clean. Why is that transistor doing that to the signal? I disconnected everything. I disconnected the base of the driver transistor, and the AF amp, the first transistor, is still shaping the hell out of the signal. And I'm looking at the circuit design, and they have the bias resistor. They have one bias resistor going to ground from the base, and they have the other one going to the collector, and that seems wrong to me. Seems to me that that resistor should go from positive rail to base, and then from base to ground as a voltage divider, because that would feed the AC back from the collector onto the base. And why would you want that? That doesn't seem right to me. So if I drive the signal generator directly into the base of the audio driver that drives the transformer for the outputs, I get a really clean sine wave from 300 hertz up, almost 4 volts peak to peak on the speaker. But the moment I go back to the stage in front of it, it's just trash. And I've checked, there's only 3 resistors, a transistor, and a coupling capacitor. Well, 2 capacitors. There's 1,000 ohm from the emitter to ground with a bypass capacitor, a 27K and like a 5K bias. That's it in the transistor. How could this not work? What am I missing here? God, these AM radios, they're either so easy or so tough. And I'm just thinking I'm going to take a break from these things after this, because they're not, most of them, half of them, or more than half of them, are just really tough to fix. The most simple circuit can be so difficult. All right, well, Mr. Golden Honeytone, Mr. Honeytone, I am sort of officially giving up on you. And I usually don't do this, but I bet I've got 6 hours or more fighting with this, and I've gotten nowhere. The issue appears to be with the AF amp. So it comes out of the volume control through a 1 microfarad right here. Then it goes into the base of the AF amp. The AF amp has like a 20K from B plus to the collector. The emitter has 1,000 ohm, which is right here. And that 1,000 ohm is paralleled with a 22 microfarad capacitor. It then has a bias arrangement of a 6K to ground and a 27K to the collector. Now, I thought that was kind of funny, so I took the time and went and dug through and looked up a bunch of schematics, and that is a way they do it. Now, there is feedback through these resistor dividers here, through this red electrolytic, to the emitter of the driver. So that is feedback from the output on the speaker back into the emitter of the driver. That's not where the problem is occurring. The problem is occurring in the AF amp. I have removed every resistor. I have changed the transistor. I changed the driver transistor. I replaced the capacitors again. I looked at this thing with a microscope and a flashlight. I cannot see anything wrong. I don't know what is wrong with this. I mean, I'm tempted to build it out on a breadboard and see if it shapes the signal the same way this thing is shaping the signal. But what I have found is you turn it on. This is 22K. What I found is if I put a 22K in parallel with the bias resistor from collector to base, it's impossible to do with one hand, but what I found, if I put a 22K resistor from collector to base, it kills enough gain on that first audio transistor to where it stops motorboating and works. Did this thing ever work out of the factory? I don't know. I would be tempted to ask that question, AXED. But right now, I've giving up on this one. Usually I don't give up, but yeah. This might be one for the record right here, because time spent is running the clock of my life out, and I can't do that anymore for this thing. I don't know what's wrong with this. Like I said, I know where the problem is, but I've changed every part in the circuit and it still won't work. And no, I didn't overlook anything. It's just, I don't get it. So it's going to get modded with a 22K 8th watt resistor if I can find one. Or if I can find a chip resistor, I'll put that in there, a surface mount.
That American families that built America, the backbone of this nation, were betrayed not just by the left.
I put a surface mount resistor right there. That noise, I believe, is it's the camera.
Dodgers Clubhouse Show presented by Nabby and Tankless Water Heaters. The Dodgers 10 runs on 16 hits. They had one error. The Reds 5 runs. Donation of $1 million or $10 million. There's no cap on it. And as long as they fill out the form, it's legal to do that. And he has raised money from Facebook. Yes, we're taking on the rhinos, and you're absolutely right.
Should call this shitty tone. There's K Mozart, LA Oldies. I tell you, this would be a great candidate to strip all that crap out of there and put an LM386 in. Single IC, just completely strip all this stuff off here and just come right out of the volume control into the LM386. Yeah, I mean, this would really be the ultimate contender for that. Yeah, I don't know. I don't want to spend any more time on it. I got the board on the Honeytone all cleaned up. And I also talked to the owner. You can see our little chip capacitor there. And I also talked to the owner about stripping this audio amp off of here and replacing it with an LM386 chip. And he said, yeah, why not? And hopefully it improves the sound of it. We'll take one last listen here and we'll do another video. We'll just strip all of this stuff off and replace it with an LM386 module. Probably need to check the speaker first to make sure the speaker's not bad.
It held that the abortion right, which is not mentioned in the Constitution, is part of a right to privacy, which is also not mentioned. And that privacy right will observe. Take care. Okay, bro. Can you still say God bless you in this country? Over? You can? Well, God bless you. God bless America. In about 2 or 3 months, he was more back to his normal self. But we still have sympathy. Over 50% today on a signature live and tune service and 24-point inspection. Normally 2 lanes.
So an LM386 will drop the current down, increase the performance, the sound quality, all of that. I don't like making radios not original, but I mean, I got it working okay, I guess, but it doesn't sound good. And, you know, high fidelity sound is very important from a radio like this. You know, why would you own a Honeytone if it didn't sound sweet? This radio is from a previous video that I completely struck out on getting the audio amp section to work right, and I just want to start with a demonstration of what it sounds like. This is clearly a problem in the audio amp, because if you listen to the detector output with the signal tracer, it's clean. So what we're going to do is I'm going to strip everything off in the audio amp, the driver, the preamp, and the audio output, and I'm going to replace it with an LM386 module. This is sort of an experimental video. This is an LM386 module. These cost about $1. Of course, and you can see that it'll fit cleanly in place of the two transformers. You can buy these for about $2. That's probably a counterfeit IC because the Texas Instruments genuine IC off DigiKey is $2. So that's, yeah, probably a counterfeit. But I'm going to clean all of the amplifier parts off. This is like 5 to 12 volts, and you can set the gain on this chip from, I think, 20 to 200. I don't know what it's set to on this board. You can screw with a feedback capacitor and adjust the overall gain. Here it is with a gain of 200, gain of 20, gain of 50, bass boost, AM radio power amplifier. So we're not going to quite use the right thing here. We're buying it pre-made. I got the LM386 module in the Honeytone here, and it works a hell of a lot better, except it's a little bit deaf and it still sounds like crap. I did have to make a couple modifications because this being PNP germanium, ground on this thing is actually positive, right? So positive is the major foil, which is ground. So one side of the volume control was tied to positive. Well, this being a little bit more modern than this over here did not like that. So I had to add a capacitor. I had to add a filter capacitor right here from basically B plus to ground. And then I had to add another capacitor here from the volume control to the module. And I had to change the module low reference, meaning all the way down where that side, from battery positive to battery negative, because this thing would just sound like crap. So the first thing I'm going to do is I'm going to pop it on the generator here, and we'll check the IF alignment and see if that wakes it up a little bit. But like I said, on the germanium radio, the low side of the volume control is connected to battery positive. This did not like this. I had to change the low side of the volume control to battery negative and add a filter capacitor, a little bypass capacitor, and a isolation coupling capacitor to this. And I got it all nicely done with Teflon wire, and it's in there pretty nice, but it still sounds like trash. I don't know if it's the speaker or what. It's freaking Honeytone. Oh crap, no wonder why it's deaf. Oh wait, I think that's the oscillator. Oops. Can't turn that one. Okay, this one's a problem. Okay, I got it. Yeah, that one seemed way off. Hopefully that wakes it up a little bit. Alright, let's do a quick band scan. The idea was to take a bunch of these radios we've worked on lately out to the desert and do a actual real sensitivity training test. A sensitivity test out away from the city, but that's not going to happen because I guess it would be more relevant for the sound to be intelligible if the what I was listening to was intelligible, if I could understand it. This is America. Nothing's in English anymore.
My mom needs a defective detector.
I'll get one too. All right, so you've hurt someone you love. How do you say sorry in a way that makes a difference?
With a Glock 19, of course.
Celebrity All-Star Game in West Covina. I was out in the second lane from the left. Looks like CHP got there and cleared everything over to the shoulder. They're a good match. Now, passion out of its users, isn't it? To the point of in their firstborn. We need to find Ray a mutt.
So it literally sounds like